Hey everyone. So this lesson begins kind of a shift in our conversation. Uh, this is where today is going to be easy, I think, but the next two lessons after this get a little bit more algebraic, and students tend to find them a little bit harder. Okay, so just something to keep in mind. When something's harder, that doesn't mean we shy away from it. It just means that we're going to need to do a little bit more practice with it, okay? Today, though, I think will be straightforward. Now, just a reminder, this is our third lesson in this unit. What we've done so far is we've talked about the concept of slope and how to find it using the slope formula, or if we were given a graph, just using the concept of rise over run. Then in the last lesson, we talked about parallel and perpendicular slopes, and we looked at the fact that the slopes will be the same when two lines are parallel, and when two lines are perpendicular, which means they intersect at 90-degree angles. For those guys, the slopes will be negative reciprocals of each other. So that means we flip the sign and we flip the fraction itself as well. Where we now shift is looking at equation writing for a line, okay? So we've been drawing lots of lines in the last two lessons. You drew 2 points and you connected them. And even in the last unit, we were drawing lines by creating a table of values or finding the x and y intercepts. But there are 3 ways we represent the equation of a line. And that's what the next 3 lessons of this unit are all about. Today is super straightforward. It's called slope y-intercept of a line. And we're going to take some time to unpack it, but you're going to find it very straightforward. Tomorrow is slope point form, and then we end with general form. Now, where it gets harder with tomorrow and the next lesson is that your algebra skills have to kick in, because we'll start rearranging equations. And we'll go from one form to another form to another form, okay? So today is fairly easy because we're not switching forms, but that's where it's gonna get more complicated, and something I want you to think about even while we start today's lesson. Think about the algebra behind what you're doing so that you can start feeling comfortable as we go through these last 3 lessons together on switching forms, isolating for one thing, getting rid of brackets, getting everything over to one side, all of those sorts of things you're going to hear in these last 3 lessons, okay? Okay, so I've given you here a bunch of different lines, okay? And below, I have a table where essentially you're going to figure out the slope and the y-intercept for every line, okay? So for example, this guy here is line A. Okay, and so the slope of line A, well, I can see the y-intercept right away. Let's just start there. The y-intercept is 5. I need to get another friendly point for that guy. So I know the 5. If I follow down that line, it looks like this guy here would be another friendly point. So I could find the slope by going down 1, 2, 3, 4, 5, 6, and write 1, 2, 3. So 6 over 3 reduces to 2 over 1. So let's look, 1, 2 over 1, 1, 2 over 1, 1, 2 over 1. Okay, so that's what we're doing. Now, in the table I provided you, I've already given you the equation of this line. And what we want to do is we want to write down all the slopes and the y-intercepts, and we want to compare the slopes and the y-intercepts to what the equation of the line is. So what I'd like you to do first is fill in the table yourself, okay? So find all the slopes and find all the y-intercepts for each one. Okay, so what you should have gotten is a slope of 2 and a y-intercept of 0, 5, a slope of -0.5 and a y-intercept of 0, -2 for B. For C, a slope of 1, 1 over 1, and a y-intercept of 0, -2. For D, a slope of 1/3 and a y-intercept of 5. For E, a slope of -1 and a y-intercept of -6. For F, a slope of -2 over 3 and a y-intercept of 5. And for G, a slope of 4 and a y-intercept of 0, -7. Now, what do I want you to see? Well, there's lots I want you to see. There are two main things I want you to see. I want you to see that the y-intercept always seems to be this last number here. You see that? Every time the y-intercept is the last number of this particular equation. Okay, so that's one thing I want you to see. The next thing I want you to see involves the slope. The slope always seems to appear as this number in front of x. Remember, if there is no number there, that is the number 1. So every time the slope I found seems to be connected to this front number, okay? And in fact, it is. So all equations above are written in a specific form called y equals mx plus b. When the equation of a line is written in the form y equals mx plus b, there is a significance to m and b. And predict what's going to happen? Well, our prediction will be m seems to be the slope. It seems to be connected to the slope. That was the number that's in front of x, okay? And b seems to be the y-intercept. Okay, so use your results to complete the following table. So what's the slope and what's the y-intercept? Well, slope here is 1. That's the number in front of x. Y-intercept is 7, so the point will be 0, 7. Remember, when you're writing intercepts, it should always be as a coordinate point. For b, the slope is -3/4, and the y-intercept is 0, -1. When you're writing the slope, don't write the x. It's just the number in front of x. If you write -3/4x, that would be considered wrong. That is not the slope, okay? For c, the slope is -4/3. There is no b value here, so the y-intercept is actually 0 or 0, 0. It's the origin. For d, the slope is -1, and the y-intercept would be 0, 8. And for e, the slope is 2, and the y-intercept is 0, -7. Okay, so that's the first 5 in your table. Then you had these guys. For f, the slope is -4, and the y-intercept would be 0, 5. For g, the slope is 1/4, and the y-intercept would be 0, 2. For h, the slope is -5, and the y-intercept would be 0, 0 again. And then for I, notice that there's no x, which means there's no number in front of x, which means the slope is 0, and the y-intercept is 0, 4. That actually would be the y-intercept. A reminder that that would be a horizontal line, y equals 4. Y equals any number is a horizontal line at that number, and x equals any number would be a vertical line at that number, okay? Awesome. Okay, so now we're going to take this one step further, and we're going to build the equation. So we're going to take a look at A. For A, we want to find the slope, we want to find the y-intercept, and then we want to create the equation. Okay, so you should have gotten a slope of 2/3, a y-intercept of 4, and so the equation is y equals mx plus b, y equals 2/3x plus 4. Okay, for b, you ended up with a slope of -1/4, a y-intercept at -2, and so the equation is y equals -1/4x minus 2. Your slope ends up being the number that's in front of your x, and your y-intercept ends up being the number that's by itself at the end. For c, you should have gotten -3/5, a y-intercept for the slope, a y-intercept of 0, and that would have given you the equation y equals -3/5x. Give d a shot, and you should have gotten a slope of 4, a y-intercept of 3, and that would give you the equation y equals 4x plus 3. Okay. For e, you should have gotten a slope of 2/3, a y-intercept of 1, and that would get you the equation 2/3x plus 1. We're going to pause with e and just make sure everybody understands what's going on. Okay, so I had for e is right here. Here's my y-intercept at 1. Okay, that's where I hit the y-axis. From there, I go up to over 3, and you can see that I'm right back onto the line. So up to over 3 each time gets me back onto the line. So that's why I know that's the slope. Okay. All right, for f, you got a slope of 2 and a y-intercept of -5, and so that creates the equation y equals 2x minus 5. For g, you have a slope of 0, Why did I say that? Because you can see it's a horizontal line. It's no rise and all run, okay? The y-intercept is -5, and so the equation becomes y equals -5. And then for each, that's a vertical line, that is all rise and no run. So that would be something over 0, which would be undefined. The y-intercept doesn't exist in this one, and the equation would be x equals -4. Remember, the slope of the equation of every horizontal line should be y equals whatever the number is, and the equation of every vertical line should be x equals whatever the number is. Okay? Awesome. Okay. Draw a sketch that predicts the appearance of the graph of the equation y equals -2x plus 4. Use your graphing calculator to check your prediction. Don't worry about your graphing calculator yet. We will have that conversation in the next unit when we talk about linear systems. I'm not going to deal with a graphing calculator just yet. Okay, so what do we do? Where do we start? Well, we can start at the y-intercept because that's a point that I absolutely know. So I know I hit this, where this graph hits at 0, negative, or 0, positive 4. So I put a point there at 0, 4. Now I need to think about the slope. Well, my slope, what number is in front of x? It's -2. So either that means I go up and to the left or I go down and to the right. Both of those would give me a negative slope. So I'm going to do them both. Then I get 3 lines and I can take my straight edge, some sort of a ruler, your ID card from school, credit card, something that will allow you to draw a nice straight line and connect those 3 dots together. So I went up to back 1 and I went down to over 1. So I've applied my slope and then I connect the dots. Make sure when you are connecting the dots, couple of things. Number 1, you are drawing a line. So don't just go from the first dot to the last dot. You have to go through the dots, okay? This line goes on forever and ever and ever. So make sure that you're not showing me a line segment. Make sure you're showing me an actual line. So go all the way past the dots you've created and make sure there's arrowheads on either end because that says that you're going to keep going forever, okay? All right, so we are now very, very confident to say slope-intercept form of the linear function is in the form of y equals mx plus b. M is absolutely your slope. B is absolutely your y-intercept, okay? Okay. When we are determining the equation of a straight line, we need 2 things. We need a point and a slope. If the point we're given is the y-intercept, then we're in luck. We can go right to y equals mx plus b and fill in our equation, okay? So the graph of a linear function has a slope of 3/5 and a y-intercept of 0, -4. Write the equation of this function. Well, I know my slope is 3/5, so that's my m value. And I know my b value would be the y-intercept, which would be at -4. So y equals 3/5x minus 4. That is the equation that fits those parameters. Okay, it's as simple and straightforward as that. M is your slope, b is your y-intercept. Okay, so write the equation in slope-intercept form for each. I have an x-intercept of 3 and a y-intercept of -8. Now I gave you the y-intercept, that's at -8. So that's your b value. You know your b value will be -8. I did not directly give you the slope here though. So what you have to do is find the slope. In order to find the slope, you need 2 points. Well, you have 2 points. You have the x-intercept, which is at 3, 0, and you have the y-intercept, which is at 0, -8. So you're going to plug those 2 guys into the slope formula. M equals y2 minus y1 over x2 minus x1. Okay. And then that gets you a slope of 8/3. So now I know my slope and I know my y-intercept. I'm ready to build the equation. Y equals 8/3x minus 8. Okay? All right, so let's try an x-intercept of -9 and a y-intercept of 5. Again, I'm given the y-intercept, so I know my b value is 5. Again, I'm given 2 points, so I'm going to use those 2 points, plug them into the slope formula. The x-intercept is at -9, 0, and the y-intercept is at 0, 5. Plug those into y2 minus y1 over x2 minus x1. And I get a slope of 5/9. So now I know 5/9 is my m and 5 is my b, so I write it in the form y equals mx plus b. Okay, good. Determine the equation of each line. So again, if I'm given a line, I get the slope and the y-intercept. plug it into the equation. So for A, my y-intercept is at -4. Looks like my slope, I need to find a nice friendly point. There's a nice friendly point. So that would be what? 1, 2, 3, 1, 2, 3, 4, 5. So 3 over 5x minus 4. Y equals 3 over 5x minus 4. Okay. For B, let me draw this in for you just in case you're having trouble seeing it. So I have a y-intercept of 6. I need to find another friendly point. This looks like a nice friendly point to me. So I'm going to go down 1, down 6 over 4. So that's a slope of -3 over 2 when I reduce. Okay, so -3 over 2 x, and then plus 6, my y-intercept. Okay, for C, C is right here. I'm just going to switch color there. C is here, and so I end up with a y-intercept. Sorry, it's not letting me switch color, and I can't figure out why. Oh, because I didn't draw. Never mind. Okay, so -5 here. And looks like that's a friendly point too. So really, each one of these are a friendly point. My slope is -1. I'm going down 1 over 1, down 1 over 1. So it'll be -x minus 5. Okay, and then for D, I have a y-intercept at 0, 0, so there's no b value. My slope, got to find a nice friendly point. If I go up 3 over 1, up 3 over 1, that works, so it'd be 3x. And then for E, I've got a horizontal line up here, so that'd be y equals 7. Okay? Okay, write an equation for each of the scenarios described, then use your equation to answer the question. So the cost C to take n students to the theater is $3.25 to rent the bus and $8.25 per ticket. Find the slope, find the cost to take 64 students. So when you're creating the equation, remember in our last unit, we talked about creating the equation, and it was always the dependent variable equals the rate times the independent variable plus the initial cost, or the cost of nothing. So in this case, the cost of nothing is the $3.25. Then it costs $8.25 per ticket, so that'd be $8.25n. So we've got C equals $8.25n plus $3.25. Now, it said find the cost to take 64 students. Well, did I give you a C value or did I give you an n value? I gave you an n value. So we're going to plug that right in for the n, and we're going to solve. And we get $853. Okay, so the total cost is $853. The taxi fee, T, is $3.60 to start, plus 55 cents for each kilometer driven, D. Okay, so my cost of nothing is $3.60. That's my B value here. The B value, the y-intercept, is the cost for nothing. So I'll be T equals, and then at 0.55 D, make sure you use the letters that you were given. That's an important thing, okay? Plus 360. So T equals 0.55 D plus 360. The total cost of the trip was $23.95. Did I give you a D value or a T value? That's the total cost. So I plugged $23.95 in for T, and now I have to algebraically solve for D. So I'm going to subtract 360 from both sides, and then I'm going to divide both sides by 0.55, and that gives me 37. So the distance driven was 37 kilometers. Okay. A water truck delivery arrives with 2,500 liters of water. The number of liters of water, L, remaining in the truck at time t minutes, decreases at a rate of 120 liters per minute. So that's my rate. Just be careful, it's decreasing, so that'd be -120 for my M value. And my starting value, I start at 2,500. So it would be L equals -120T plus 2,500. Okay, now how long would it take to empty the tank? How long would it take to empty the tank? Well, that means what time is it when my L is 0? That's when the tank is empty, okay? So I'm gonna replace L with 0, and I'm gonna solve for T. So I have to subtract 2,500 from both sides, and then I'll have to divide both sides by negative 120, and that gets me 20.83. So my conclusion is it would take about 21 minutes to empty the tank. Okay? Okay, so hopefully this feels straightforward. Remember, slope y-intercept is always y equals mx plus b. M is always your slope times the x value, and then your b is your y-intercept. Okay, so give your homework a shot and make sure you touch base with me. Let me know how you're doing, and let me know if you have any questions. Okay, take care, guys.